and a small omega notation. So first is a small O notation. Small O notation, okay, it's a very similar to big O notation. The only difference is here. In the previous big O notation, this is smaller equal. But now, it's a strictly smaller here. Okay, the equal sign is gone. All the other part remains the same. And you could use the same, equation abuse, but we don't use this very often. Okay, we just don't use this very often because usually the big O notation is similar. But you just need to remember, the only difference between big O and small O is here. The equal sign it doesn't hold. Okay. So omega, big omega and the omega, the difference is also here. Okay. And obviously, this one, okay, the big O hold, the small O obviously is also true. Same thing, okay. For big omega, this one, we have this, but for small omega, this is also valid. Okay. You could use different N0 and the C. It's up to you, but the same, if you use the same set, you need to be careful that equal will not appear. If the equal sign holds, okay, you need to pick a different set of N0 and the C. So now we formally, introduce all these terminologies. Okay, but in reality, how do you solve them? Of course, you could use this very formal notation. Okay, this very formal notation. To find N0 and the C, all the time, but it's pain in the neck, right? It's pain in the neck. There are certain, how should I say, you learn some tools in your calculus. Okay, because you are second year, right? The freshman. In the freshman year, you took the calculus, right? The calculus tells you a rule called L'Hospital, right? You don't recall anything about that? L'Hospital. Actually, I learned that in high school. Okay, but something you can see the growth rate of two functions. So F and G. When n goes to infinite, okay, you can try to differentiate the functions, right? Just to verify, if this is okay, then there's a relationship between these two, right? You can differentiate the numerator and denominator. If you forget, your calculus teacher, your calculus professor will be very sad. Okay, he or she should have told you that, right? 我们那时候在高中的时候，好像我记得高中老师叫我们叫这个叫什么红笔头，你们应该学过吗？没有吗？应该有吗？对 you should have done that like in your calculus class. Okay, it applies either to like when the limit goes to infinite, when this ratio becomes 0, or when this ratio goes to infinite. I mean, when this ratio goes to 0, obviously that means what? That means g grows faster than f, right? Then g will be the upper bound for f. And if this thing goes to infinite, that means like f grows faster than g, right? So obviously that this has something to do with like this big O, omega notations, So you could use some calculus tricks, okay, calculus tools to help you to solve this like to prove that okay a certain function grows faster, it's relatively easy to use this type of stuff. I mean, if you forget, I'm not your calculus professor, so I am not responsible for your learning in calculus, but please go back to check. There are certain situations, actually a lot of situations, the calculus, especially the differentiating part, is really helpful, like in computer science. Okay, later on, when we talk about, for example, if you want to get into AI field, okay, we talk about like gradient descent. Okay, gradient descent basically is calculated as slope. And when we talk about slope, like we talk about slope in calculus all the time, right? 斜率是什么？ First order derivative, right? So that's like also something you should remember, okay, from calculus. For like integral. Integral is more commonly used in other disciplines. Okay, I'm not saying it's not useful in computer science. It may be useful in certain areas in computer science, but not as much as differentiation. Okay, 积分用的比较少，微分用的比较多。Okay, so you should pick up some concept or some stuff like from your calculus. Okay, if you forget, go back to your calculus like notes. Okay, if you have taken the calculus notes or your textbook to check like this stuff. Okay, I will just stop here because I'm not teaching calculus. Okay. So that's like the first subject, okay, of this lecture. Okay, we talk about big O, big omega, theta, small o, small omega. These are, what should I say, like the language we use to describe like complexity in our class. Okay. So when we talk about in the future, when we talk about like algorithms, we use these notations all the time. Okay, but as I say, like don't worry, like the only two stuff we use more often, big O and the big fat, big O and fat. Okay. And then, okay, it's about the second part of this lecture is about recurrence. solving recurrence. Okay, I mean, solving the recurrences, like it is, you see recurrences a lot, some from time to time. Okay, recurrence happens, especially in algorithm, when your algorithm like is recursive. If your algorithm is recursive, I mean, a lot of time your complexity, when you write it, when you write down the complexity, the formula will be a recurrence. Yeah, you guys know the definition of recurrence, right? It's just like a function can be defined, okay, but it's like lower terms. 就一个方程式，你可以用它比较小的一些 term 来表示它。Then we call it recurrence. Okay, I mean the easiest like example that you guys have seen. I mean we talked about that last week. Is merge solve, right? Merge solve. What is merge solve? Merge solve is like f of n equal to 2 times f of n divided by 2 plus bit of n, right? Right? That's pretty much like the recurrence like for the merge solve. Okay, just like what I said, because merge solve is a recursive program, right? Merge solve is a recursive program. I mean, I don't need to give you like a definition of recursion, right? I mean, you should have done that from your programming, right? Programming class. Okay, so the nature, source of recurrence formula, as I said, is the recursive program. But of course, it may come from other places. Okay, I'm not saying recurrence must come from recursive programming. Anyway, just want you to understand, when we say recurrence, that means like the function is defined by its lower terms. Okay, plus some additional, stuff. Like, then we call it recurrence. Okay, so to solve this type of recurrence, okay, there are, so recurrence also, by the way, I mean, when we solve like integral differential equations, okay, we also find recurrence. Okay, for example, like I teach like linear algebra. Okay, I think some of you are in my class, right? So the last chapter, if you remember, we talked about using the linear algebra to solve a system of differential equations. Okay, and that could be another source of recurrence relation. Okay, so that's, basically but in computer science, of course, especially in this class, recurrence most likely comes from a recursive program. Okay, so we need to solve the recurrence. What do we mean by solve the recurrence? We have to represent your function f of n only by by n on the right hand side. Okay, it could be a polynomial, it could involve exponential, whatever. But we want to get rid of those smaller term of f of n. 就是我们右边，我们希望就是用 n 的那个方程式啊，就不要再有什么那个比较小的 f of n 在右边，就是我们希望把那个消掉。 it's just like in the merge sort example we talked about last week. We use I try to explain to you why it is like unlock value, right? We discussed that last week, right? Okay, so that's like something. Okay, it's kind of like we try to solve that recurrence relation. Okay, so the next topic in this lecture involve like solving recurrence or solving recurrence relation. Okay. I mean, divide and conquer algorithm. Every time you see divide and conquer algorithm, the recurrence relation comes up. Like we discussed, like complex. Okay, but there are other. It could be like a dynamic programming, other stuff. But anyway, okay. So let's take 10 minutes break. When we come back, we'll continue talk about like how to solve recurrence relation.